I'm going to call this Chapter 7, Section 4, Part 1. We are adding and subtracting polynomials, rationals. What's another word for rationals? Rationals is the grown-up way of saying what? Anybody remember? Fractions. All right. Before, guys, we were multiplying and dividing, right? Where you factored everything, whatever, God bless you, whatever canceled out, we could cross out, all that good stuff. When you add and subtract fractions, what do you have to have? A common what? Common denominator. So I have 1/2 plus 3/5. Can I just add that together? No. I can multiply. I could say 3/10, right? Multiply numerators, multiply denominators. But you can't just add and subtract until you have a common denominator. So what would our common denominator be between 2 and 5? 10, right? So how do you figure out the equivalent? Well, 2 times what gives me 10? 5. What you do to the bottom, you do to the top. So 5 times 1 is 5. Plus 3 times 2 is 10. What you do to the bottom, you do to the top. So 5 times 2 is 10. So 3 times 2 is 6, right? So now when you add this, sure. Now when you add this, you get 11/10. Everybody with me? We're going to do the exact same thing, guys, with polynomials. Today we're going to talk about just like denominators that are the same. And then Tuesday, Wednesday, we're going to talk about ones that are different and how to get a common denominator. So this is what I just said. Exactly what I just went over with numbers is what we're saying here. Notice, guys, what can C in both of these examples never equal? 0. So when you have a denominator that has a variable in it, we have to define what x cannot be so it doesn't become 0. So what I need to see from you guys, right? Here's A. I have 7/4x plus 3/4x. First thing we do, guys, notice, are the denominators the same? Yes, since they are the same, you can write the numerator together. What this becomes is just 7 plus 3. Everybody with me? What is 7 plus 3? 10. So this becomes 10/4x. I keep the denominator the same. You add the numerator since there's an addition sign. Can I simplify this? Yes. I have a 10 and a 4. What number goes into both 10 and 4? What is it? 2. Right. If I divide the top by 2, I get 5. If I divide the bottom by 2, I get 2. Correct? Now, this is your answer, but you also have to tell me what x cannot be. So you set your denominator not equal to 0. Divide both sides by 2. What can x not equal? X cannot be 0. What happens if it is? Then your denominator becomes 0. Then your whole fraction becomes undefined. Everybody with me? All right, now, and I want you guys to get into this habit, please. I know it's very basic right now, but you need to get into this habit when you have a subtraction sign. Let's look at B. First thing I say is my denominator the same? Yes, all right, so I'm going to write it one time, x plus 6. Now I'm going to write my numerator. I have 2x minus 5. Everybody with me? Now, it's important, guys, if you had like 5x plus 3, remember, this negative sign would distribute throughout. So make sure you're paying attention to that. That's why I think it's a good idea for you to write your numerator together so you can see it. But what would this become? Well, can you subtract 2x minus 5? No. Okay. So this is all I can do here. Is anything on top and bottom exactly the same? No. I cannot just cross off the x's. Remember, that 2x is stuck with that negative 5. And the denominator, that x is stuck with that positive 6. Anything that is added or subtracted together, they're stuck together. So this is your final answer here. Now you have to say what your x cannot be. So I'm going to say x plus 6 cannot become 0. Well, what's going to happen? How does it become 0? I'm going to subtract 6 from both sides. So what is the value that x cannot be? X cannot be negative 6. Because think about it. What would happen if you plugged in negative 6 there? What's negative 6 plus 6? What's negative 6 plus 6? 0. Okay, good. All right, questions. Okay, let's go through a few more. This is super basic today. I know that. Common denominator, yes? Okay, so I'm going to write my numerator over my common denominator. I have 8 minus 5. What's 8 minus 5? 3. So this is 3 over 12x. Can I simplify? Yes, 3 goes into both those, right? 3 goes into 3 one time. 3 goes into 12 4 times. So my simplified answer here is 1 over 4x. Now there is a value that I cannot use. What is that value? X cannot be 0. What happens if x is 0? Then your whole fraction becomes undefined. We good? All right, let's look at number 2. Common denominator? Yep. So your numerator is 2 plus 1. What is 2 plus 1? So I have 3 over 3x squared. Can I do anything with that? Yeah, I can divide. 3 goes into 3 once. So I have 1 over x squared. That is my simplified rational. What can x not be? X cannot be 0. If you said x squared cannot be 0, you take the square root of both sides, right? So x equals, when you take the square root, what goes in front of your answer? Plus or minus. Is there such a thing as plus or minus 0? No, so it would just be x cannot be 0. Okay, let's look at the next one. You guys are doing good. This is easy. I like this. Common denominator? Yep. Okay, so my common denominator is x minus 2. Let's take our numerator, 4x minus x. Can I simplify that? What's 4x minus 1x? 3x over x minus 2. Is there anything else that I can cross out? Yes or no? Can I cross out my x's? No, because that x in the denominator is attached to your negative 2. So here is your simplified fraction, your rational. Then I have to say x minus 2 cannot be 0. So what do I do to both sides? Add 2. So x cannot be what number? Positive 2. What happens? Think about it. What happens when you plug positive 2 in? 2 minus 2 is 0. Fraction's undefined. All right. Common denominator? Yep. So my common denominator is x squared plus 1. So I have 2x squared plus 2. Now what? Can I combine the top? No. But can I factor anything out? What can I take out of 2x squared and a positive 2? I can take out a 2. So when I do that, this becomes x squared plus what? 1 over x squared plus 1. Anybody notice anything? Yeah, they cancel out because they're the same. So your answer here is just 2 when you simplify. Now think about this, guys. Let's figure out what the denominator can't be. Well, if I say x squared plus 1 cannot be 0, I subtract 1 from both sides, right? How do I get x squared by itself? Take the square root. So x cannot be plus or minus. What's the square root of negative 1? 1i. Good, it's I. So are there any domain restrictions here? No. I can put any number I want in there and it'll never, ever, ever make my denominator 0. Any negative number, when you square it, it becomes positive. You add 1 to it, it's a number. Any positive number, you square it, add 1, it's a number. Plug in 0, 0 squared plus 1, 1. So there are no domain restrictions. All real numbers work here. You could say negative infinity to positive infinity. So let's look at some of your homework problems. This is on the homework. You guys have homework. If you want to do this with me, you can. If you don't want to, I'm going to just do a couple of them. Let's do the odd ones. So let's look at number 3. If I look at number 3, common denominator? Yes, right? So 4x, and then I add 15 plus 5. What's 15 plus 5? 20. So 20 over 4x. What does that simplify to? 5 over x. Good. So there's your simplified rational. And what can x not equal? What's the only number x can't be? 0. Because what happens when x becomes 0? Then your whole fraction is undefined. Let's look at 5. Common denominator? right? X plus 1. So my numerator is 9 minus 2x. Can I combine that at all? No. Can I factor anything out? No. So we just say it right here as 9 minus 2x. And then I have to say, well, wait a second. I have a domain restriction here. If I set my denominator not equal to 0, what happens? If I subtract 1 from both sides, what can x not equal? -1. And then just check, guys. Just look at that and say, okay, let's just make sure. Think about it. If you plug -1 in right here, what's -1 plus 1? What's -1 plus 1? 0. So then you're like, oh, okay, yeah, that makes sense. All right, let's look at 7. Common denominator? Yes, so x plus 3. Then you have your numerator, 5x plus 15. Can you combine 5x plus 15? Yes or no? No. But can you factor anything out? Yeah, I can take out a 5. And when I factor out a 5, if I divide this by 5 and this by 5, I'm left with x plus what? Perfect. Over x plus 3. Now what do you guys notice? These two cancel, so your simplified version is just 5. But you do have to go up because if I set x plus 3 not equal to 0, subtract 3 from both sides, what can x not equal? Cannot be -3, because if it does at the beginning, God bless you, if that does, when you plug in -3, -3 plus 3 equals 0, then your fraction becomes undefined. Does that make sense? Okay, you guys work on 4, 6, and 8. By the time we're done with our notes on Wednesday, all of your homework should be done, and then you can just submit it. If you're following along with what we're doing, you guys should be able to finish all of your homework in class without having to do anything at home. And then we'll start on 7-5 on Thursday.